Example, and this is the situation where we're running a test. It's a left-tailed test. You can read it if you want to, but this is my null and my alternative hypothesis. In this particular case, they give me the population standard deviation, and they give me a list of values, right? Now there's 17 values here. Unfortunately, I didn't input this prior to doing this video, so we're gonna do it together. Whatever, that's a good review if we forgot how to input values. So I have to put the values in my calculator first. So I'm gonna go stat, and then again edit, if you remember. And I'm gonna put it into L1, so I'm gonna highlight L1 and go clear enter to clear out that list, because I want fresh. So 197, enter, and if you want to, you can fast forward this. I have to put all these in, I didn't do it prior. 126, so you can put them with me if you want. You can fast forward, whatever you need to do. 160, 142, 162, 144, I'm going as fast as I can, 119, 190, 160, 142, right, we're gonna go through this process, 211, 148, nah, don't mix up your numbers, 114, 202, and 250. Okay, now I'm just going to quickly check and make sure. See, I'm on the 18th value, which means there's 17 above that, and there's 17 values here. Quick check. I'm not going to go through and check all the numbers and make sure they are correct. I probably would if I were actually doing my assignment, right? But I'm just showing you the process here. So if you're given a list, you have to put it in to your list, and I put it in L1, and again, stat and edit to anytime you want to input a list into your calculator, and you have to do that to tell it where to pull the information. And again, second, quit, I go back to my home screen. Now you guys know that if sigma is known and you're doing a hypothesis test regarding a mean, you're going to use z-scores and things like that. So on the calculator, it's going to be z-test. Write that again, z-test. And just like the last problem we did, if you looked at all these videos, we did z-test here. I'm going to do it again here. Stat, scroll over to test. Z-test is the first one. And if you guys remember confidence intervals, when you went to t-interval or z-interval, they both had this option whether you to use data or stats. They're the only two that have that. So it's the same idea if sigma were unknown and you were given a list of values. In this particular case, I'm going to go to data because, I don't have the statistical values. I could find them, but I'd rather just put them in my list and let my calculator do everything. So when I go to data, you'll see it asks me for a list. But again, it asks me for this value that's, basically dealing with whatever we're claiming, our claim. So 150 is the value that we're dealing with, mu naught. And then sigma was sigma 34, that was given to me. I put my list in L1, so that means that I need to pull up L1 second and the number 1 to pull up L1. My frequency is 1 because I don't have a second column or anything. Just leave frequency is 1. And then down here again, tell it what type of test that you're dealing with. Mine's the left-tailed, so I'm going to scroll over to highlight less than mu naught. So this is saying my alternative that the mean, population mean, is less than the claimed value. I don't care about the color. I'm just going to calculate. I don't care to draw right now. We're just dealing with the values. You could look at that yourself if you want. And then my output. And remember I told you it's always alternative hypothesis, test statistic, p-value. That's always the order in which you get your output for all these things dealing with hypothesis testing, z-test, t-test, whatever. It's alternative hypothesis, test statistic, p-value. And then it gives me the sample mean and sample standard deviation if I want that, and obviously the sample size if I want that. And again, this does not give me the critical value if I'm running or using the traditional method, or the critical value method as I think this book states it. But again, because the critical value would be a z-score, then I would need to go second bars down to inverse norm. And then, you're finding the critical z-score corresponding to whatever area on your graphing calculator. So this kind of goes back to those videos that we did before. So again, if I'm doing z-test, it only gives me test statistic and p-value. obviously I can still run my test, but if I want my critical value, I have to go second bars, okay, to pull up inverse norm if it's a z-score. So this is how we find our, little values for our hypothesis testing if we're given a list of data values, right, instead of, the statistical values, okay?